All right. So we got a couple things from the chat. So Greg Zegan gave, who I think I mentioned in my last stream, was going to start his own live stream doing an RPG Maker. Well, he started it. I saw part of the first episode, so it's a good, I think, long-running project if you want to see a longer project progress over time. He's going to get through that a lot faster because he's going to be focusing on the same project week after week. But yeah, in the chat, he was giving a couple links to a project called LinkSF. Let's see. I'm not sure if that's something he personally has been involved with. Let's see. And Greg, it looks like the links got a little messed up, at least the way my chat is showing them, but let's see. LinkSF. So he says, this is a project for homeless and low-income people to find services, which uses React and Firebase. The mobile-optimized website connecting homeless and low-income residents with critical and life-saving resources. And I guess it's sponsored by Zendesk. That's cool. And he gives the link, GitHub as well. Talks about history. Yeah, I'm interested to watch this video later. Talking about the Tenderloin Tech Lab. Yeah, so actually, a friend of mine, Michelle Glosser, has been running programming workshops out of the Tenderloin Tech Lab, and actually, I should talk about this too. She has just, for people in San Francisco, she's just launched this nonprofit called Tectonica, which is a boot camp. It's going to be a free or a no tuition boot camp for low-income women and non-binary adults. And she's running the Kickstarter or the Indiegogo campaign right now. So if you're interested in donating, I'll probably be talking about this more next week on the stream. But this is a great organization that is really starting to find workable business models to bring tech education and training programs to low-income people, and get that financed by the tech companies in San Francisco that have a lot to gain from it, but also are causing a lot of the problems in San Francisco as well. Cool. All right. And then, so great. We had a suggestion of looking a bit more into how to write JSON decoders iteratively. So in the one I just wrote, I kind of just wrote it out of my head all in one go without doing steps in between. So Arkham was giving a good suggestion of how to do it, so I'd like to walk through the steps that he was suggesting as well and give that as an example. So the idea here is if we have some kind of JSON structure that we need to decode, but we don't want to do it all at once. We kind of want to take small steps and try things out as we go along. So let's do this. I'm going to define for this zip code. Let's have a new value in here called mayor. And under that, we're also going to have a name. And then we're also, let's see, what I wanted to add here was terms. And then under terms, we're going to have a unique ID. I was just reading a little bit about lists in Firebase. And the way you do it is you're supposed to use their push function in their API, which will automatically generate a unique ID that also sorts correctly in order of date. But I don't see a way to generate those IDs from this console. So for the moment, rather than ID, let's just put a placeholder in here. And then in this first term, we're going to have a start, which was, let's see, 2011 in November. And then also, oh, you can only add one thing at a time. Okay. And we're also going to have an end, which was 2015 in November. Then he was elected for another term in 2015 November. Okay, so let's take a look at decoding this kind of data structure. So we have a person, there's terms, and then the terms have their own JSON structure as well. So let's try to do this iteratively and use the approach that Arkham was talking about in the chat. So first of all, let's see if we broke anything. I think this all works fine because we've only added fields. We haven't changed anything that it's trying to decode, and if there's extra fields, that's fine for the decoder. All right, so here's basically the trick that Arkham was suggesting, that we can start at the top level, and actually this is a pretty good approach if you want to do this iteratively. So we know we're gonna have a new field here, and it's gonna have some data type, but we don't want to have to decode that yet. So we're just gonna put temporarily JSON.value and basically just get a chunk of unparsed JSON for the moment so that we can update our zip code info decoder to work properly. So this is kind of like a top-down iterative approach. An alternative would be to start with the tiny pieces at the bottom and build working decoders for those and work back up. That can be good if it's easy for you to kind of build, get examples of the subchunks, especially if you are writing a lot of tests for this. But if you're kind of doing interactive debugging development like we are today, then working from the top down is a reasonable way to approach this. Okay. Oh, I guess I don't need this window. What I need to see is, do we have compiler errors? And in fact, yes, we do. Okay. So here's the first thing we need to fix. We've updated the data structure that we're trying to decode, and now the zip code info decoder is incorrect. And this message is not the most helpful, but basically it needs a function. And it's because this thing is now a function that takes two parameters, which means when we apply one parameter, what we get back is still a function, not a zip code info. So we need to change this to take two parameters and decode two parameters and pass them to zip code info. And then the second thing, we're going to have decode at mayor, and I need to check the docs for the decoder. Is there a way that just gives us a value back out? Do a case sensitive search here. Let's see. I want a decoder that just gives us the value back. Is there even such a thing? There should be a decoder. That's interesting if there isn't. Maybe one of map. That'll take another decoder and give it back. Succeed. Ah. Actually, yeah, we can do that. Ooh, okay. And there's value. Okay, here we go. This is it. So we want to just say decode.value, and this will just give us the value straight out. I was realizing another way we could do this incrementally is just put the succeed decoder in here and just say like succeed with a unit value or something like that. But then we wouldn't be able to see it in the data structure if we were printing it out or debugging it with toString like we are in our app. Okay, so we're going to use decode.value, which will just give us the JSON value back out. All right. Cool, so we have successfully compiled. Reload. And you can see here we got mayor, and then we got this JSON structure. Cool, so that's our first incremental step. So now let's dig down and yeah, okay, let's use person info is actually what we want, and we're going to be modifying person info to decode the terms as well. So now we're going to use our person info decoder to decode the mayor also. And let's see, is this compiling? Cool, that compiled. We'll refresh, and now we get the name. But what we'd like to do is update the person info to also take terms. The terms is going to be a list, but right, we're going to do this incrementally. So for now, let's just decode a JSON.value for terms. And now we get a compile error, again because we've changed the number of parameters in person info. So now we need to use object2, and we're going to decode at terms decode.value. And that compiled. Let's try this out. And it looks like nothing happened, so I'm assuming that the decoding failed. And I have a guess as to why that is, but let's figure out how we can get the error message. So here in our decode zip code data, we're getting the results, which includes the error message, and we're converting it to a maybe, which throws away the error. So right in here, I'm going to debug.log. Or actually, let's make this so that it only logs the error. So we can say result.mapError debug.log coding error. So this is going to say if we get a result, which is an error, it's going to call this function on the error message, which you normally use for transforming errors into different types, but in our case, we just want to log it. And okay, so map error is not the correct name, but there is a function of that type, I believe. So let's find it. For in result, mapping, chaining, error with default. Here it is. It's called format error, not map error. So this just lets us apply a function only when there's an error. So let's make sure this compiled. Okay. All right, so here's our error. Expecting an object with a field name terms at police chief, but instead got this. Okay, so what we want to do here is make sure that terms is optional. So this is good because we can focus on the error just at this one level without having like lines and lines of code that we need to sort through. So let's make this a maybe. Code.maybe value. And that should fail to compile. Okay, so let's just make this a maybe JSON value for the moment. That compiles. And now, oh, it's still expecting the same thing. That's interesting. I was expecting maybe to succeed if that wasn't the case, but apparently that's not how it works. Expecting an object with field name terms at police chief, but we just got a name. That's interesting. So there's no thing named terms. There's no key named terms. Just double check if we add this. Terms. Okay, so if we add that in, it works. So let's read the docs for maybe in the decoder. So it says it extracts a maybe value, wrapping the just and turning any failure into nothing. If you're expecting that a field can sometimes be null, better to check for that explicitly. This function will swallow errors from ill-formed JSON. Interesting. So this is maybe not the best way to do it, because the decode at is going to fail if there's nothing of that name. Yeah, so Arkham is suggesting we need one of. I think that might be the best approach here. So I'm going to take this out. Instead, we're going to say decode.oneOf, and then we'll have some choices. So we're going to say decode at terms with a value. And actually, this is going to work out a little nicer anyway. So we'll make terms just be a JSON value. And if this fails, then we'll just say JSON dot string. So this is coming from the encode library. So this is maybe a little tricky to use JSON.value. Oh, right. And then we need decode.succeed. Okay. Yeah, so this is getting a little complicated. So we're going to try this decoder. And if this fails, which it will if there's no terms, then we're going to succeed with this value. And in our case, we're using a JSON.value as a placeholder, so we have to create one. So that is a little confusing in this case when we're using the JSON value placeholder. Okay, so we've got our mayor, we've got terms, and it's got the JSON in the terms. And okay, let's go back to the console and delete the terms for Tony Chaplin. make sure this can still decode everything. And yep, okay, so it changed the terms to be no terms here. Great. So our next incremental step is going to be to get rid of JSON.value, and instead this is going to be a list. Let's just do one step at a time. There can be multiple terms, but we'll have a list, and we'll start with just having a list of JSON values, and then later we'll turn this into terms. Now we should have compile errors. So here, our terms, we're going to decode a list of JSON values for the moment. And if there's no terms field, we're just going to succeed with an empty list. And with that, everything should compile. Great. Okay, so let's reload this. And we can see Tony has no terms. And interestingly, Edley didn't get terms either. Oh, right, because this is not actually, the terms are not actually a list in Firebase. They are just a dictionary of keys that are sorted by ID. So I guess actually what we want here is a dictionary. So we're going to get to go through some fun stuff with decoders today. Not what I was expecting to cover, but it'll be fun. So we're going to decode a dictionary. We give that a decoder of the values, and it gives us a dictionary back, which has the keys as strings and the values as whatever they're decoded as. Okay, so rather than a list, we're going to get back a dict of strings as keys and JSON values as values. That means we're going to use decode.dict here, and we need to import dict. All right, and then we have a mismatch here on line 39. So if there are no terms, or if there's no terms key to even attempt decoding, we're going to succeed with a dict.empty. And that compiles. So Tony has no terms, and Edley has a bunch of terms. Cool. So a property of dictionaries in Elm is that when you convert them to lists, they are sorted by the value, by the key. So actually, if we convert the Elm dictionary into a list, it'll all be sorted in the proper order because of the way the Elm dictionaries work internally. So I'm going to take this whole decoder where we produced a dictionary and transform it by saying decode.map. Is there such a thing? I think we saw in the docs there wasn't. But basically, we just want to apply a function to this whole dictionary. We'll do dict.toList. Let's see what errors we get. Great. And now what we end up with is not a dictionary anymore, but we get a list of tuples. And actually what we want to do now is just drop the keys, because we don't care about the keys. They were just used for sorting. So we're going to do another decode.map. And what we're going to apply to this list is we're going to call list.map and call snd to extract the second value from the tuple of each item in the list. So just to make this a little more explicit, we can map with an anonymous function where it'll get a term, or actually no, it'll get a key and a value as a tuple. We're going to destructure that tuple and just return the value. So I'll refactor this back to what I had in just a second after we get this rest of this working. Okay, so now what we've produced is no longer a dictionary, it's a list of JSON values again, like we originally wanted. So let's make sure this works, and then I'll refactor this last line. Works again. Cool. So here we've got Tony. He's got no terms. And then we have Ed, who has 2 terms, and inside of each term is a JSON value currently. So now, just to explain this again, so here we made an anonymous function that's destructuring the tuple, where we have a key value pair. So this is equivalent to just taking, actually I'll leave this for the moment. I'll copy this line. So this with the key value destructuring is equivalent to taking the KV pair and calling SND on it. And this is just a function in, I think, the basics package in the core library that just takes the second value out of a tuple, just like we were doing here with our anonymous function. Let's reload. And that still all works the same. And then this, creating this anonymous function because of the way currying works in Elm, since KV pair is the last parameter to this function call, we can just remove all of this. Actually, let me just copy this line one more time so you can see the comparison. So we can simplify this and just say SND as a function. And as soon as that compiles, just make sure it works again. Cool. So yeah, so this is just a simplified way of writing what we originally did using an anonymous function to destructure the second value of the tuple. All right. So now we've got our list of JSON values. Let's keep digging. And now, instead of getting a list of JSON values, we want a list of term info. Yeah, I'm not sure if I necessarily like this pattern of calling everything info from what we're decoding, but I just kind of arbitrarily started doing it in today's episode. So we'll see how it plays out. Now we want to decode term infos instead of JSON values. So that means we're going to need to define it. Term info. So we're going to have a start, which for now will just be a JSON value. And we're going to have end, which will also be JSON value. And actually, the end is optional. So let's let's just do the start for the moment and come back to the end. All right. So now we're expecting to decode the terms as this, but they're currently being decoded as values. So here's the problem. So we want to define a new decoder, term info decoder. It's going to be a decode.decoder of term infos. And this will start off the same way. We're going to decode an object 1 for the moment. We're going to use term info. And then we're going to decode.at start. And for now, we'll just use decode.value. Then we'll actually pull out the date a little bit. All right, so what's wrong now? So object 2 is expecting the third argument to be a decoder of lists of term infos, but it's actually a decoder of a list of JSON values. Oh, right. So we just wrote this decoder, and now we're going to use that here instead of the JSON value decoder. And all right, we have success compiling. So what did we get? So we got start and start here. So we don't see the end in here anymore. So it looks like we're successfully decoding our records. All right. So our next step, we're going to bring back to the end. So I'll add it to our term info. Now our decoder is object 2. And we're going to decode at end. And I think we'll have the same problem we did up above, where if there is no end key in the JSON, this is going to fail. But let's just try this quickly and verify that that doesn't work. So we're going to decode a maybe JSON value. That compiled. So let's reload. And yeah, okay, so that failed in here and we ended up with no terms. So rather than doing the end, we're going to decode one of, and we're going to try decoding at end. And if that doesn't work, then we're going to succeed with a JSON string. Oh, well actually we can succeed with nothing, because this is a maybe. We'll succeed with nothing if there is no value in here. And I'll also note that this can all be simplified a bit with the JSON pipeline decoding library, which I would like to show at some time in the future. Maybe I should be using that by default in general, but all right. So here we have our start, we have our end, we have our start, and there's no end for the second term. But hopefully that'll be coming eventually. All right. So now we've decoded term info. Start and end are both values, however. So we would really like to make these dates, I guess, but let's make them strings for the moment. I'm going to do two steps at once here. Make these both strings, get compiler errors. Now, instead of decoding values, I'm going to decode string for start and a string for end. Cool. All right. So I guess since we're hard into decoders here, we may as well try decoding these dates manually by ourselves. So there is a package, I think the date extras or something like that, which lets you parse dates. And I think maybe even the JSON decoding pipeline package includes that built in. But let's just do an example here of how to write a custom decoder. All right, so I don't have date because we haven't imported it. So now let's go down here, and instead of decoding strings, we'll call decode date. And that doesn't exist yet. So for now, let's just put a placeholder in here. It'll be decode.succeed. And how do you create dates? You say date.fromTime, I think. Okay, so that compiled. Cool. All right. So here's kind of our placeholder. So what we'd like to do is make a custom decoder. We're going to parse the string. In our case, we're parsing just the month, or a year and a month. We don't have a date in any of our strings. So let's see if we can write a decoder to do that. I guess we should just rename this to be called decode month while we're at it, since that's all it's going to do for now. Okay. So there's a couple ways you can do this. Oh, well, no, I'm wrong. There's only one way you can do this. I was thinking there were a couple different functions, but I was thinking of the same function. We're going to use this custom decoder that takes another decoder to start with, which will give us something. Then we provide a function that transforms whatever that thing is into a result, which could give an error or could give a success. And we'll get out a decoder of that success case type. So let's give it a try. We're going to say decode custom decoder. And then what we're going to start with is the string decoder, because we know this value needs to be a string. You can see an example right up here of using a custom decoder with JSON values if you're doing something really complicated. But in our case, we only want to try parsing the date if we get a string to start with. So I'm going to use decode.string. Then we're going to have a function. So I'm going to make this an anonymous function. And I'll call the parameter dateString. And for now, let's give just an error of not implemented. And let's make sure it compiles. Good. We'll refresh. And now none of the terms are parsing because we're getting errors. And we're not seeing the errors because they're getting swallowed by these one-ofs. So let's see, can we make that show up? So this is if the @ fails. Just take the succeed case out temporarily. Yeah, that just gives us the error on Tony. Okay. I don't see a quick, obvious way to get the errors to display. But what we can do is take this whole thing and say decode.map, debug.log, code month. Let's see if that works. I'm surprised that is not... Oh, I'm sorry. This is the decoder that we're mapping, which will only map if there's success. So actually, I guess what we want here is debug.log at the end of this function. All right, wait for that to compile. There we go. Okay, so there's our not implemented error. Okay, so now let's try parsing the string. Let's check in our core package and see what nice string functions we have. I haven't done a lot of like low-level string manipulation in Elm. So we've got a split, and there's also regex.split. Why don't we just use that, or a regex.match? Let's try using regexes here, just to make sure we don't get weird errors like 3-digit years or 3-digit months. Okay, so we do find. We're going to tell it how many to find. We're going to give it the regex and the string. We'll get back a list of matches. Okay. I think this might get a bit complicated. Yeah, now that I'm thinking about it, I think it's actually going to be simpler to just split the string on dashes and verify it that way. So let's start with splitting. We're going to split on dashes, and we should get two results back. And if we don't, there's an error. So let's do a case of string.split. We're going to split with dashes, and we're going to split the date string. And if we get a list of year string, month string, then we're going to do something in a second. And if we don't get a list of 2 items, we're going to have an error. Expected a month, but got date string. And we'll stick this up here. And this is meant to go around the case. So I'm going to put a bunch of extra parens. We'll get rid of these parens later when we delete the debug.log. All right, let's see if this compiles. String.split, we need to import. All right, so that compiles. And we got not implemented. So Arkham is suggesting using date.fromString. In this case, that's not going to work because we don't actually have dates. We just have a year and a month. So I'm pretty sure date.fromString won't work for that particular case when there's not actually a day of the month specified. All right. Let's see. So if we have year and month, let's try to parse both of these. So we're going to have, I think it's in string.toInt. Nope. It basics. There's string.toInt. there should be a function that converts strings into integers. I'm sure I've used that before. Does it just turn into a number? Not in there. Lacks string to number and number string function. Parse int. Feed int. Here we go. String to int. Yeah. Why didn't I see this earlier? Did it get removed? String.toInt. Oh, there it is. Okay, not sure how I missed that before. So let's do a case and parse both the year and the month at the same time. String.toInt of year string and string.toInt of the month string. And if we get a year and we get a month, then well, I guess we're still going to say not implemented for the moment. And if we get anything else, we're going to say error. We expected this. And these are results, not maybes, so this is okay. Okay, so we still get the not implemented. So finally, we need a way to make our date. Let's see. Is there a way to build one from the components? Huh. Maybe this was all unnecessary. Date. That looks like we're gonna have to turn it back into a string anyway. Alright, so if we have this, then we're gonna do date.fromString of the toString year. Oh, this is getting ridiculous. Actually, I'm just gonna say string.join with dashes. Have toString year, toString month, and 0, 1. Or I guess just a 1 at the end. I guess we've got a case on this again. And if we get a date, then we're going to return the date. Otherwise, we're going to return this. Okay. So this is obviously becoming a mess. We got November 1st, 2015, November 1st, 2011. Okay, so we ended up getting all that. I was thinking there was a date function that just took the year and month as integers. So yeah, I guess in alternatively to all this, we could have just taken our date string, done a case to parse the date string plus 0, 1. Just tacked on the day of the month in there. And you don't need any of this. Okay, that compiled. Oh, interesting. So that actually gives the wrong dates if we do that. So there's time zone issues. Interesting. So, okay. So for using date objects, there's lots of time zone stuff. So I guess this is all kind of, oops. This is all kind of a little weird to be writing this code when we're not sure how things are going to be used in the end. So why don't we do this to end up? For today, I'm just going to backtrack a little back to where we had all these cases. And if we get a year and a month, let's just return that as a tuple. So rather than a date, let's return an int. So let's call that a month. And we'll type alias month to be year is an int. And the month is an int. So then if we get a year and a month, we're going to return OK of a month with the year and the month. We can kill all of this. Then here, we need to go back up to our start and end are now months rather than dates. That compiles. And now we get our data structures. And let's do one test here. If we corrupt this, like put an XX in here, then, okay, great. We get expected a month, but got 2015 11XX. And in that case, what was it? That was the end of the first term. And now we get a nothing for that. And if we fix that, instead make the start unparsable, then now we don't even get that term because the start is required to be a valid month. Okay. So now we can delete the debug.log, delete these extra parentheses. So what did we do? We split the date string on dashes, made sure we had exactly 2 values, inted those, so tried to parse those year strings and month strings into ints. And if we got those, probably we should also do some bounds checking on that. So yeah, there's an example of a custom decoder. That was a bit crazy, and I would say for a real use, if you were decoding months, you should probably use one of the other Elm libraries rather than doing it yourself. But I thought it might be interesting to show a custom decoder example. Yeah, so I think that's it for today. I'm going to leave it here. We got way sidetracked doing decoders, but that was kind of fun. And yeah, I would encourage everyone again to, especially people in the United States, do a bit of research on your own and find out your local community and your local police department and leadership council. Find out their stance on police violence, what they're trying to do about it, if there's any information about police reforms that they've tried to implement and haven't been able to for some reason. And with an election coming up, especially if there's going to be important local elections in your neighborhood, be sure to make sure that police violence and racism is an important issue for your local candidates. and ask the questions, do the research, and share what you find out with people you know. So yeah, that's all for today. Thanks for tuning in, and thanks for being a part of the Elm community and making it a great place, and hopefully making it an even better place in the year to come. So I will see you all, I think, next week. I'm 90% sure, but you can watch on Twitter, which I'll show in a second, if you want to get notified, or subscribe on Twitch if you want the last minute email notifications. So thanks everybody for tuning in, and I will see you all next time.